Okay, so today we will discuss functions in C++. Okay. Okay, so in C++, I can classify the functions into four kinds: call by value, call by reference, call by constant reference, and call by address. Okay. So call by value and call by address, which you may have termed it as call by reference in C. Okay. Or you are familiar with that, right? But then a new thing that probably has been introduced in function in C++ function is the reference, right? Call by reference again, and call by constant reference again. So in C, when you have classified the functions with respect to the arguments into two kinds, right? Call by value and you say call by reference. The call by reference of C, I am calling it as call by address. Okay, but then I am introducing reference variables here in C++. Fine. So if you are passing that reference variables as arguments while calling the function, I am calling that as call by reference. But if that reference variables are preceded with constant keyword, we have a constant variables available in C++. So if I pass constant references, then I say it is called by constant reference. Okay. Before moving on to here, again, I just wanted to make you, clarify what the reference variables. Okay, what is the difference between the reference variable and the pointer variables? Okay, so we'll first have a difference between these to be clear before we move on to looking at the demonstration of the classification of or taxonomy of functions. Okay, so let us look at here the difference between the reference and the pointer variables. Okay. What is pointer? The pointer is a variable which holds the address of another variable of same type. Okay. For example, if I have a variable, let us say a variable which is an integer, right? And a variable is a pointer, right? Why I say this is a pointer variable? How do you identify that a variable is a pointer? When a variable is preceded with asterisk. This is said to be asterisk, which you can find the symbol on your keyboard being used for multiplication rather, right? So if a variable preceded with an asterisk operator during the declaration, we call this as the pointer variable, right? Now I am introducing another variable called a reference variable. Okay, ampersand b. Now I said ampersand b equal to a. Okay. Now this a is a variable, integer variable, all right, or normal variable, I can say. Whereas here, b is a reference variable, right? So here, if you look at it, you can see the difference, right, between a normal variable, pointer variable, and a reference variable. It is very clear here. You can see if you declare a variable with a name, fine, when you are declaring as some type, like for example, integer variable, you want to declare. How do you declare? In giving a space, then followed by the variable name. Okay. So variable names, we have certain conditions to declare the variable names. Right? Variable name can include special character underscore, okay, and it can be declared with a 30 character length, and you can start with alphabet, fine, and it includes digits, lowercase and uppercase, fine. So with the guidelines given in C language, you must have declared the variables, right? So the same kind, of course, I'm probably adopting here. Generally, what we do, instead of giving the variable name to be a larger one, we generally take the variable as a resized one, which can give you the meaning resized to the situation. Okay, so generally, to declare the variables to hold certain integer numbers and all, A, B, C kind of thing you can probably take, or X, Y, Z and all kind of thing you can take. Let us say if you are trying to represent some name, you say you take it as name, student name you want to represent, so you can say S name or STD name or student name kind of thing, right? You generally take the variable name which is rather meaningful for that respective context, right? But then ensure that it is as short as possible and at the same time can give the precise meaning to that respective situation, right? So you can see here A is declared as a variable, but this B is P. I'm saying it as a pointer variable. See, it need not to be P. It can be X, or it could be PTR, or it could be some name. Like if you are probably using this pointer to point to certain name or certain salary or account or any other kind of thing. So based on the situation, you can take that name. But then it is not that pointer. When I am declaring, I need to take the variable name as P. You can take something else also, but then P stands for pointer, so I have taken it as P. Okay, that is a only difference, but otherwise not. You can take any other name for the pointer, right? Like how you can declare a name for any variable with the guidelines given, with the rules given. Similarly, pointer also the same kind of guidelines are given. You can have the pointer name also of that kind. Okay, with 30 character length, including lowercase, uppercase, with a special symbol that is underscore and all that thing, right? But then how do I identify that it is a variable of pointer kind? When a variable is preceded with asterisk, this asterisk you can see here, asterisk symbol. So when a variable is preceded with asterisk symbol during the declaration, this is the declaration, right? So during the declaration, I say that is a pointer variable. Okay. Now you can see how do I identify that a variable is a reference variable? Here I am saying B is a reference variable. How do I say? When a variable is preceded with ampersand, this is ampersand, right? And you can find on your keyboard, which is being basically used as an address operator, right? So a variable preceded with an ampersand, I say it is a reference variable. Okay. Now coming to the point, why reference variables, right, are required, and what is its basically the use, rather, right? Reference variables will just act as an alias name to the actual variable, right? The second name, right? For example, a person is called in the college as Raj Manohar Shastri, but then at home he will be called as Raj, right? Or say Raju, or say Gudu, some kind of pet name. So I mean, a person will have an alias name, right? A name in the college records for official purpose. At the same time, at home or in among his friends and all kind of thing, he will be referred with some other name, right? A pet name or other kind of thing, right? But both of them are pointing to the same person, right? So very similar, right? Rather, same memory location. When you want to point to it with another name, you use reference variable. Of course, pointers were also doing the same thing, right? Pointers were also doing the same thing. It is the way of indirectly accessing the memory, right? So generally what happens when you declare a variable A, when you declare a variable A, for A, memory will be allocated, okay? So as you know that memory, when I say memory, it's nothing but the system memory, is nothing but the internal memory, or sometimes there are multiple names for the internal memory. Sometimes you call it as volatile memory, preliminary memory, primary memory, you call it as RAM. Okay, all these names, of course, rather, right? Okay, so the memory, when you look at your memory, fine, the system memory, it is available in the form of bytes. Okay, the entire memory is divided and available in the form of bytes. Each byte carries 8 bits. Okay, basically this bit is nothing but some kind of flip-flop, right? If you have studied logic and switching theory, probably there you must be studying about the flip-flop concept, right? Generally flip-flop holds a value either 1 or 0, right? Okay, so a flip-flop generally you find T flip-flop toggled and a D flip-flop, SR flip-flop, and JK flip-flops, right? So generally, most of the time the flip-flops are JK flip-flops, because in SR you will find a race condition. Of course, these all you study as part of hardware and all, because at the beneath, if you see, it is the hardware only, right? we are enabling the hardware device to carry out our respective tasks. See, computer is an electronic device, right? It's an electronic device, but our program, the program which you give, which is carrying some set of instructions, right, that enables this electronic device to carry out the required task which is suggested by you, rather, right? So of course you study as part of computer organization and microprocessor and all, how the hardware being controlled by your computer, your program, how this program will help in controlling the required devices are available in your computer, and make them to perform to your satisfaction and all kind of thing, right? You probably study there anyway. So just I wanted to bring to your notice that the memory which is available in our computer is available in the form of bytes, right? And each byte will have a unique address, right? It means every byte will have a unique address. So it means the memory will be identified with the help of address, right? And the addresses are generally represented in hexadecimal format, which are unsigned. That is the reason why you must have seen in C language the format specifier that you have taken for memory address to print %u, right? %u, %d for integer, %s for string you have used, and %f for float, ld for long int, and lf for double, and all kind of things are studied, right? So similarly, %u was the format specifier which was being used to print the memory addresses, right? Because they are unsigned, right? So let us take now. Let us consider it as a program. Okay. So when you declare a variable of integer kind, what happens inside the system? As per the C knowledge that you have gained in the last semester, you may have known that for integer 2 bytes is required, right? In general. So 2 bytes of memory being allocated per array, and as I said, every byte will have a unique address. The first byte address is the base address, fine, because if let us say 2 bytes are required for A, the 2 bytes will be allocated at the same place. It means in contiguous locations, right? If 1 byte is available here, the other byte is somewhere else, it doesn't happen, right? 2 bytes at a stretch, right? It requires for A. So 2 byte as a whole, wherever is available, that will be allocated. And who is going to allocate this memory? Is all being done by the operating system, right? You have an operating system on your computer, otherwise you can't run the program, right? So you have probably in mobile also you have Android operating system or iOS and all kind of thing, right? So operating system is another subject that you're going to study in 3rd year, right? Operating system basically acts as an interface between the user and the hardware, right? It provides a lot of functionalities for you, rather, right? It provides memory management, process management, disk management, file management, okay, resource allocation, all that it does, okay? Without which you can't do anything on your computer, right? And most of you must have familiar with what happens when the computer starts. What happens when the computer starts? Anyone from your class? When you switch on the system, what happens? It's Jyoti. Are you there?
Okay.
Yeah, what happens when you switch on the computer? See, when you switch on the computer, what happens? Yeah? Someone is giving answer?
It will start working.
Yes?
It's ready
Your voice is
to.
not clear.
It is ready to start. Starting
Yeah,
Windows
what happens? How is it going to
appear.
start? Yeah, how is it going to start?
No idea, sir.
Okay, let me, it's okay. Then mute, I'll give you the answer, right? So what happens when you switch on the computer? There is a bootstrap loader program, right? There is a bootstrap loader program available in your internal memory. There are two parts in memory. You have RAM and ROM, right? RAM is the random access memory, and you have read-only memory, another part, right? So in this read-only memory, you will have this bootstrap loader program. Okay. So what happens when the computer is switched on? There is a program control register, right? So this program control PC register, wherever it points, CPU starts executing that particular instruction. Fine. If I have to execute my program, okay, when I give my program to the computer, PC is processor register, right? Available. There are a couple of processor registers available as part of the computer, right? Instruction register, register, all kind of thing. Like within that, you have a program counter register, PC, right? So where PC points, from there the CPU start executing the instruction. CPU is what your central processing unit, right? So the central processing unit carries control unit, ALU, arithmetic logic unit, and you have a memory unit, right? So this control unit basically will control the entire thing. So control unit will enable the required functions and the inputs required for the multiplexer in the common bus and required controls of the processor registers to be rather enabled for transfer operation, for carrying out the ALU operations, and all kind of thing, right? So you have these all you're going to study as part of computer organization, of course, right? So the CPU, right? Who is going to rather execute the instruction? I can say the other way around. Right, the complete computer operation is going to be done by the CPU, right? So what CPU does? From where it start executing, right? Which particular instruction it has to execute? The instruction which has to be executed by CPU is going to be told by whom? Is the PC, right? Program counter register. The program counter register will hold the address of the instruction to be executed. So what CPU does? The address of the instruction held by PC, it will get onto that instruction and start executing. So what happens when you switch on the computer? The entire hardware of your computer make the PC to point to the first instruction of the bootstrap loader program. So where PC is pointing? It is pointing to bootstrap loader program. So CPU start executing what? Bootstrap loader program. So when you switch on the system, what happens? Bootstrap loader program is going to be executed. And what is this bootstrap loader program is? Loading the operating system programs from the hard drive to the RAM, to your internal memory. Fine. So this process is called booting. This process is called booting, right? So first what happens is when you switch on the system, the other way around I can say, the operating system programs from your hard drive are going to be loaded onto the main memory. in your internal memory, right? So in your internal memory, in your RAM, there is one specific position. The lower part of your RAM is reserved to store the operating system programs. Fine. So what happens is when you switch on the system, the operating system programs available in the hard drive are going to be loaded into that respective specified position of the internal memory. And once they are get loaded, when you switch on the system, someone was saying starting Windows. The starting Windows is nothing but the Windows operating system is being loaded from your hard drive to your internal memory, right? The lower part of your internal memory now will have all the operating system programs being loaded with. And they're all available as processes. They're ready to provide the services, right? They are ready to provide the services. They are available in the form of, we call it as daemon process or daemon process, right? So they are running in the background to provide you the services. What kind of services operating system is going to provide? Allocation of resources, access the resource allocator, right? It provides the process management services, right? It provides disk management services, file management services, all that. Your program, when you're giving a program, until it executes and gives you the output, who is going to help you out? Operating system, right? So what do you mean by program? Program is a set of instructions, right? But then this program has to be driven. Yes or no? These instructions have to be conformed. How does these instructions are going to be conformed? Only when it comes into the execution, right? Or who will bring it into the execution? The operating system, of course, right? Who is going to execute? Of course, the CPU, rather, right? So the instructions, when they are being executed by the CPU, you say it is a process, right? Your program will be transformed into a process, right? Got it? There is a difference between a program and a process, right? Program is just a set of instructions which you write on a white paper, right? Which are now writing. But when you give it to the system in the system operating system, rather, right? Windows, or it could be Macintosh, or it could be Unix, right? Any other kind, fine. So this operating system will take your program and transform it into a process. Got it? Transform it into a process. Process is nothing but the program under execution is called process, right? So when the program is being executed or it is under execution, I say it is a process. Fine. So who is going to transform? Of course, the operating system. But then who is going to execute? The CPU is going to execute. Yes, sir. So I think you got now a little idea about what is a process, what is a program, what is operating system, what is CPU, and how does all these resources that are available on our system are going to help me out in executing my program. Okay, now coming to, as I said, when I declare a variable like A, what is happening? Memory is being allocated. How much memory? 2 bytes of memory being allocated. 2 bytes at a stretch, wherever you find as a whole, right? The operating system will allocate for you, right? And this memory will have some address, as I said. So let us consider the address of this memory is, let us say 100 or 200. Okay, let's say 200. Okay, so the first byte address is enough to probably point to the entire memory, because these 2 bytes are available as a stretch, right? And first byte of this memory, let's say 200, then obviously the next byte will be 201. Okay, got it? So first byte is enough for me to point to the entire memory. Fine. The first byte address, I'm calling it as a base address, right? So now this A memory being allocated whose address is 200 plus. Now you have created one pointer here. Why you are saying it is a pointer? Because the variable is with an asterisk, right? If it was not, if it's received with an asterisk, then I could have said it is also a normal variable. But then since it is received with an asterisk, I say it is because the compiler is going to identify it as a pointer. Now what is the pointer? Right? Pointer is one who will hold the address of another variable of the same type. It doesn't carry any value. It carries only the addresses, memory addresses. Got it? So of the same type. see, P is a pointer I have created of which kind? Integer kind, right? So I can say P equal to ampersand A. If I say this P equal to ampersand A, what do you mean by it? Ampersand is basically used as an address operator. Address of A. What is address of A here? 200, right? So that 200 now is being initialized to whom? P. So in P, what will be placed now? Pointers will hold only the addresses. Got it? So now A address is being kept in P. And what is happening? P is going to point to A as well. See, this memory, I can refer it with the help of name A, because this name memory was being created and the name of A. But then of whose address I have held it in P, so I can access this memory with the help of P as well. So this way of accessing is said to be the indirect way of access. Got it? So it means this memory, I have now two ways of accessing. One is I can access it with the help of A, another way of accessing it with the help of P. Now there is another way of accessing the same memory with the help of references is what I wanted to introduce here in this particular session, right? So you can see here, I have said ampersand B. This B is now being created as a reference variable, right? It is not a normal variable. Why? Because the variable which you have created, the time of declaration, you have created it with preceded with an ampersand operator. Yes or no? Yes. So this B is going to act as a reference variable. So then what is the difference between the normal variable and the reference variable is a question mark that you may be struggling with. Yes, that is what I'm going to clarify here. See, normal variable for which the memory will be allocated, right? But for reference variable, memory will not be allocated. Okay. Memory will not be. It is an alias name to the actual variable. So at the time of declaration, here you can see I have assigned the actual variable to whom this has to act as a reference or an alias, right? I said ampersand B equal to A. It means A is the actual variable for whom B is going to act as an alias name. So here the same memory is being pointed by B as well. Got it? B as well. So I have two names to this particular variable, to this particular memory. One name is A, another name is B, right? So it means the same memory I can now access with the help of A, or I can access with the help of B. But then I have another way of accessing is with the help of indirect way, which is nothing but pointer. So through P also I can access. It means this memory which has been created on the name of A, I can access it with the help of either A or B or P. There are three ways of accessing, right? Got it? So reference variables will act as an alias name or a pet name, you call it as, right? Or the next name to the same memory. For reference variable, memory will not be allocated, rather they will act just as an alias to the actual variable. Got it clear? I hope this is clear to all of you. And the difference between when you talk about the pointer and the reference, both are going to do the same purpose. Both are being used for the same purpose, right? To access the memory indirectly, but then way of accessing is different, right? The pointer is holding the address of the memory to whom it wants to access, whereas a reference variable will just act as another name to it, right? It doesn't get any separate memory get created, right? For pointers, memory will be created, you can see, right? How much memory is going to be created for pointer? It could be of any kind. It could be either integer, character, float, long, double, or it could be of structure kind, student or employee kind, or any other kind. Pointer requires how much memory. If anybody asks, you have to say that to hold 1 byte address. How much memory is required is what the memory required for pointer. So it's going to be varied from the computer to computer. If you have, let us say, for example, 16-bit processor, right? Basically, when you go for purchasing the computer, you probably look for the configuration, right? in configuration, generally you look for only what is the hard drive capacity, what is the RAM capacity, the internal memory capacity, what is the cache capacity, and what is the speed of the computer, CPU speed. CPU speed is generally measured in heads, right? Yeah, how many heads it is? Whether it is in gigahertz, megahertz, gigahertz, terahertz. This is how basically. But then, in addition to that, another parameter that you generally adopt while purchasing the computer is the processor size. Um, whether it is a 16-bit processor, whether it is a 32-bit processor, whether it is a 64-bit processor. Higher the bit length, the CPU speed is higher, right? So, if say for example 16-bit processor, it requires how many? 2 bytes. Pointer requires how many bytes? 2 bytes, because 16-bit processor will have the addresses with how many bit length? 16-bit length. 16-bit length is going to be equal to how many bytes? 2 bytes, right? Because pointer requires the memory to hold 1 byte address. Any one of the byte address, if you look at in 16-bit processor, will carry the 16-bit length. Yes or no? The 16-bit equivalent to 2 bytes. So pointer size will be 2 bytes. But if let us say your processor bit length is 32, then any byte address probably require 32 bits. 32-bit carries 32-bit equivalent to how many bytes? 4 bytes. If it is a 64-byte bit processor, then it will be 8 bytes. So it's going to be varied. But most of the computer, probably you may have seen in our college or olden days, they have 16-bit processors, right? Unless you go for a higher version of 32-bit or 64, you don't need the extra memory. So generally, in most of the books, if you look at, you may have seen that pointer requires 2 bytes, whether it could be of any kind, right? That is what must have been written in many of the study materials and many of the books, because that time 16-bit processor was the highest standard, right? But we got now 32-bit and 64. So based on the bit length, the memory size required for the pointer is going to be varied. In order to know that how much memory the pointer is occupying on your computer, in C we have an operator. Can anybody list out the operator with the help of which you can measure the amount of memory being occupied by that particular respective operator you have in C language? So you wanted to know that how much memory pointer is occupying on my computer. You can use that size of and then let us know the number of bytes that are being occupied by your computer for a pointer. Okay, that's fine. Good. So I think now it is clear for most of you the difference between the pointer and the reference, okay, and the normal variable. So now it means this memory I can access it with the help of 3 names. 2 ways of direct accessing, that is AB, another way of P. I can rather say this is also indirect way, right? Because the name is different, right? So actual memory being actually created in the name of A, but then that memory has been referred, or it can be referred, or it can be accessed in my program with the help of 2 indirect ways, P and P. Let us look at the next slide. Now I want to assign some value to A. I can just say A equal to 2, and I want to add some value to that same memory. I can say A plus 2 if I say, and then I am placing in B, it means the same memory again, rather, right? Asterisk P equal to B into 2 if I say, I can say B equal to asterisk P plus 5. Now I want to print all these values, okay? I can use cout here because I am writing program in C++, right? So I say C out A. What happens? When I say B, what happens? And when I say asterisk P, what happens? Right? We will just try to execute this program and see what will be the output of the same. See, the execution of the program starts from main, and you have declared a variable A. As I told, that 2 bytes of memory has been allocated for A, and then for pointer 2 bytes of memory has been allocated for 16 processor, and then you have B reference variable for which the memory will not be allocated, but at the time of declaration you have given the actual variable name to the same as A, so B will act as an alias name to A, and then you say P equal to ampersand A, then what happens? The address of A, which is number 200, is being placed in P, so P is pointing to this A, right? So now what happens here? When I, so this is my memory A, and being referred to B also, and then there is a P who is pointing to the same, right? Okay, now here what I said, A equal to 2. So in A, the value is placed as 2. So this memory is being referred to A, B, and P. B equal to A plus 2, when I say in A is, what is the value of A? It is 2. See, every memory will have 3 things, right? This is the value inside whatever you have is said to be the value, and here this is said to be the address, and these are said to be the names, right? Okay. So every memory will have 3 things: name, value, and address. So now when you say A plus 2, A is what? 2. 2 plus 2 is 4, and 4 is being placed in B. It means the same memory. In the same memory, 4 is going to be. Then what happens? 2 will be replaced with 4 here. And in the next statement, you said that B into 2. Generally, how the expressions are going to be evaluated? Yes, the right side will be evaluated, and the same will be assigned to the left hand side, right? You have LHS and RHS, right? So B into 2, the right side will be evaluated first. B into 2, what is B here? 4 now. 4 into 2 is 8, and that 8 will be placed into left hand side. But at the left hand side, what is that? You have asterisk P. What do you mean by asterisk P? P pointed memory, right? This asterisk will act as value. See, when I am using this asterisk at the left hand side, I say it is value at the address. And when I am using it at the LHS, memory at or the reference. Okay, this is the difference. This asterisk is said to be dereferencing operator. You have another name for this, is dereferencing operator, because it is referring and dereferring, right? Got it. So now let us look at this particular statement. B into 2. B into 2 means 4 was the value in that memory. Has been replaced here in place of B, and 4 into 2 you got 8, and this 8 will be placed to home. Asterisk P you said, right? If I just say P, it means this one, right? So, but P will hold only the addresses, not the values. This is some value, right? So, but then what you said here, asterisk P. Asterisk P means memory at P, means P pointed memory. That is this one. Got it? So at P pointed memory, this value will be placed. What is that? 8. So you get 8 here. Okay. Now the next statement you can see here, in the next statement you have asterisk P. Asterisk P means value at the address held by P. Value at the address held by P is 8. So 8 plus 5. 8 plus 5 is 13. 13 will be placed in B. B is here. So this value, what you get here? 30. So when I print here, C out A, in place of A, what will be placed? You can see the latest value is 13. Fine. So 13 will be printed here. And B is also pointing to the same memory. In that memory, what is the value you have? 13. So 13 will be printed. Asterisk P, when I say P pointed memory, in pre-pointed memory, what is the value here? It's nothing but 13. You get the same thing. All of them are pointing to the same memory. Okay. I hope this is clear to all of you how to access the memory directly and indirectly. Okay. Indirect way of accessing the memory can be done with the help of either pointers or reference variable. And the difference between pointer and reference is also, I hope this is clear to all of you.